Good afternoon. So in the last unit, we have seen introduction to artificial neural network and the essentials of artificial neural network. In the second unit, we see the feed-forward neural networks, in single layer as well as multi-layer. So first we go for the single layer perceptron model. So what is perceptron? Those things we'll see in the coming slides. So what is perceptron? This is the simplest form of a neural network. It consists of a single neuron with adjustable synaptic weights and bias. Single neuron with adjustable synaptic weights and bias. What it performs? It performs a pattern classification with only two classes. With only two classes means two categories or two groups. So this perceptron, single layer perceptron, performs the pattern classification with only two classes. So here if you see the perceptron convergence theorem, so how it works means the patterns are vectors. Input is vector, input layer or what we are doing, providing it as an input, that can be treated as a vector, right? So input patterns or vectors are drawn from two linearly separable classes. So based on the input data, we can draw the line. We can make it into separate groups by drawing a line. So that's what it states. During this training, the perceptron algorithm converges and positions the decision surface in the form of hyperplane between two classes by adjusting the synaptic weights. So in this process of training, to make the input data into the two vectors or output, if you want to make it into the two classes, you need to adjust the weights and bias. So that is the training of this algorithm. So it will make that hyperplane, it will make that into the two classes by adjusting the synaptic weights. So how it works also we'll see in the coming class. This is the perceptron convergence theorem. In this, only 2 points. One is it can make the linearly separable classes into two linearly separable classes. Another one is the two linearly separable classes is achieved by adjusting the synaptic weights. So this is about the perceptron convergence theorem. You need to make into the two linearly separable classes by adjusting the synaptic weights. So obviously this can be implemented with a simple function from multi-dimensional real input to the binary output, either yes or no. So it can fire or do not fire. The corresponding output neuron may fire or may not fire. It can fire or not fire by receiving the inputs from the multi-dimensional real input. So that is also, input is also a vector, right? You may have multi inputs. So that can be connected, each input neuron is connected with the all output neurons. So based on that output neuron threshold value, the corresponding output neuron may or may not fire. So that's what it does. The perceptron has just two layers of nodes. So it is two layers, and one is input nodes and the one is output node. Already we have seen that is nothing but single layer neural network. But a simple single layer neural network is called the perceptron. The perceptron has two layers of nodes. One is input node, another one is output nodes. Input nodes as well as output nodes. Often this is called the single layer network on account of having one layer of links between the input and output. So as already we will discuss that how it is named as a single layer network, as it is having only one computational layer. It is called the single layer network, even though we are having input nodes as well as output nodes, but only output nodes are performing the computational task. That's why it is called the single layer network. In other way, from input to output, only one layer of links are presented. That's why it is called the single layer network. So as a node, to make an input node irrelevant to the output, set its weight to 0. Example, if W1 is equal to 0, then the summed input is the same no matter what is in the first dimension of the input. That means we are connecting the each input node to the all output nodes, but the corresponding input node means in the input you may have n number of input nodes. Each input node may or may not require or may not receive the input, and it may not transfer the information from input to output, but the connections will exist from the each input node to all the output nodes. If there is no information means, if there is no information from the first input node to the corresponding output nodes, what do you do? You have to make the corresponding connection weight W1 as 0 or corresponding Wk as 0. Then indirectly what it gives, the corresponding input information, there is no information. Even though if you present something, the corresponding first dimensional input is 0. So that's what it gives. So when W1 is equal to 0, the summed input is same with the remaining inputs, because there is no, even though some information is presented by default at the input node, that is multiplied with the corresponding weight, means the corresponding connection link will pass no information, because W1 into corresponding input will be 0, because W1 is equal to 0. Input is with no matter, first dimensional input will give the 0 only, right? So that's what it gives. Simply, if there is no information, the corresponding connection link weight can be make it as a 0, so that no information will be passed to the corresponding output node. The weights may also become negative or higher. In that case, higher positive input tends to lead to not 5. Means weight may be positive or negative. If you are making the weights as negative means, the corresponding weights will be compared, weights and threshold will be compared, and then the higher positive input tends to lead not to fire that corresponding neuron. Here anyway, threshold is important. The threshold will be compared with the summing output, right? Summing input. The sum is the summer junction. Summing of all the inputs and weights should be greater than or equal to theta to fire the corresponding neurons. So in that case, some inputs may be positive or some inputs may be negative also. So in that case, when you are doing that summing of all the inputs and corresponding product of all the inputs and corresponding weights may cancel each other out also in that case. So that we need to take care to get the proper input. So this everything it will comes through the proper training. We need to provide the proper training to the corresponding network so that we will get the proper output. An example, what is a peceptron? Input signal on the left side x1 to xm nodes, the corresponding connection link weights wk1, wk2, wk3 and so on wkm, the corresponding synoptic weights, and all those are summed in the summing junction with a bias Vk. Now the output of the summing junction is Vk. It is given to that activation function F, and the output of the activation function is output Yk. So here if you see, when we no need to process some information from the x1 node, in that case you can keep that Wk1 is equal to 0 irrespective of your input x1 at x1. The corresponding weight value is 0 means there is no information through that connection link. That's what we have seen in that earlier statement. Likewise, the weights may be negative or positive also. Depends on your threshold value, the corresponding node may or may not fire. Even the weights may be positive or negative also to cancel each other. If one weight is plus 5, another weight is minus 5, both the inputs are same means plus 5 into corresponding input minus 5 into corresponding input, the summing of those two will become 0, right? So like this. And if we see what is the summing input here, summing output, which is nothing but Vk is equal summation j is equal 1 to m Vkj into xj, corresponding weights and inputs will be multiplied plus Vk. Vk is nothing but bias. So to get the overall output of this perceptron is nothing but simply single layer neural network. Simple single layer neural network. The corresponding output Yk is nothing but function of Vk. Vk is nothing but summed output of that summing junction. So here we have in this perceptron concept, you have discrete perceptron as well as continuous perceptron, even multi-category perceptron. If you are combining both of them, you can get multi-category perceptrons. So if you see that discrete perceptron, if you are providing the activation function, in the case only the summed input is summed input Vk, summed output Vk is as an input to the function f, which is about activation function, right? Based on that activation function type, the perceptron category is going to be decided. If it is signum function, which is nothing but signum function is represented with SIGN. The function is signum function, then it can go to the plus 1, the boundaries are plus 1 and minus 1, and input, based on the input you may get either plus 1 or minus 1. So that is, if you are using the signum function as an activation function, then it will become discrete perceptron. The same activation function, if you keep it as a S-shape function, S-shape function means there only are getting plus 1 minus 1, but here you will have a chance to get from 0.1 plus 0.1 plus 0.2 plus 0.3 plus 0.4 to plus 1. Likewise, in a similar way, based on the input, even minus 0.5, minus 0.9, it is similar to the S-shape function. So if you are providing this as an activation function, then it will become the continuous perceptron. Simple single layer perceptron architecture is nothing but simply we are having input layer as well as the output layer. So all input nodes are connected to the output nodes. You see 3 input nodes, 3 output nodes. How many connections will be? 3 into 3. 9 connections will be there from the input layer to output layer, because each input node will be connected to each single input node will be connected to all 3 output nodes. That means each input node will make the 3 connections. Likewise, 3 into 3, total 9 connections will be there in the layer. Example, so here I have not taken output layer, simply input layer as well as inputs and connection weights. So what are the inputs to these input layer nodes? Here if we take 5, 2.43 as an inputs to the corresponding input nodes, the corresponding connection weights are nothing but W1, W2, W3. Here I assumed as W1, W2, W3. Then what is the input vector here? Based on that input vector is x1, x2, x3 as 3 inputs are there. The corresponding vector is nothing but 5, 2.4, 3. Hence the summed input is nothing but summation of I is equal 1 to 3 Wi into xi. Then it becomes 5 W1 because the corresponding weight is 1 W1, W2, W3. The corresponding inputs are 5, 2.43. That's why it will become 5 into W1 plus 2.4 into W2 plus 3 into W1. So 3 into there is W3. We get corrected. So 5 into W1 plus 2.4 into W2 plus 3 into W3. Plus 3 into W3. So like this, your inputs will be multiplied with the corresponding weights. See here, what is the rule we are following to fire the corresponding output neurons? There is 3 output neurons are there, right? So in an example, so what is the rule we are following? The output node has a threshold some theta. So if we are keeping the threshold value, that theta may be 0, theta may be 2, theta may be 5, theta may be minus 5, anything. So here as a rule, if the summed input, that is nothing but summation I Wi xi is greater than or equal to theta, then the corresponding node should fires and the output y is equal to 1. Else, or if summed input is less than theta, summed input is nothing but summation I Wi xi is less than theta, then it doesn't fire. The corresponding node doesn't fire and the corresponding output y is equal to 0. That's what it indicates. We see in the example 5 W1 plus 2.4 W2 at last plus 3 W3. It should be greater than or equal to some theta. If theta is equal to 0 or theta is equal to, the summed input 5 W1 plus 2.4 W2 plus 3 W1 should be greater than or equal to that corresponding theta. Theta if it is equal to 2 means the summed input should be greater than that 2. In such a manner, we need to adjust the corresponding weights if you want to fire the corresponding neuron. In firing the neurons. So as a simple or a sample perceptrons, so in the even in Mechalapid's neuron model also we have seen like and or how this perceptron or how the Mechalapids in model works. That's what we have seen in the first unit. There if you see here the perceptron for AND is an example. So what is the AND gate? AND gate has 2 inputs and 1 output. It has 2 input means irrespective of your inputs, if you provide the weights as W1 is equal to 1, W2 is equal to 1, now you can adjust the weights and you can get the corresponding output. If you take that binary inputs 0, if it is 2 input means how many, what are the combinations we'll get for the 2 input logic gate? 0 0, 0 1, 1 0, 1 1. In the case of AND gate, when do you get that output y is equal to 1? If 0 0, both will be multiplied and you get 0 only. In the case of AND, it will be multiplied, inputs will be multiplied, right? Or here in this perceptron case, both the inputs will be summed. So if you take that AND gate, what is the combinations for 0 0? It is 0 0 1 0 and 1 0 0. For 1 1 only it is 1 1 1. The corresponding combination of is 1. That's how the logic gate AND will work out. 0 for 0 0 0, 0 1 0, 1 0 0, and 1 1 it is 1. That means for only when both the inputs are 1, then only you need to get the output as 1, or you need to get the output when both the inputs are present, then you need to get the output irrespective of 1 and 0. If you have some input, both the inputs have some positive values or some values are there, then you will get the output as some value. By using that same logic gate combinations, here how you need to set that weights and threshold means the corresponding weight should be 1 and 1, then only the corresponding channel or connection links will be activated. Connection links need to work if you provide that corresponding weights as the positive value 1 and 1. Here I have provided. In the corresponding threshold, here I have taken 2 because W1 plus W2 should be, let us take that inputs, corresponding inputs as 1 and 1. W1 plus W2, W1 into X1, X1 is equal to 1, X2 is equal to 1. If we take W1 into X1 plus W2 into X2, which is nothing but W1 plus W2, which is nothing but 1 plus 2, 1 plus 1, which is equal to 2. So minimum it should become 2. Then only the corresponding peceptron will fire, or corresponding neuron will fire. Otherwise, simply if you take even threshold value, you need to be 2 also. W1 plus W2, if you take all the inputs in that AND logic gate, it may be 0 0, 0 1 or 1 0. In these 3 cases, your AND peceptron with the AND gate will not fire, right? Because the corresponding output is 0. Only in the case of 1 and 1, only it will fire means even you can provide the threshold which is greater than 1, that is enough. 1.5 is also enough, 1.1 is also enough. If you provide 1.1, let us take for the 0 0 case. When weights are W1 plus W2, corresponding inputs, anyway that is 0 only. 0 into W1 plus 0 into W2 is equal to 0 only. So which is less than that 1.1. So obviously the corresponding neuron will not fire. In a similar way, 0 1 inputs if you take 0 into W1 plus 1 into W2, that becomes 1. 1 is also less than 1.1. In that case also your neuron will not fire. 1 0 inputs if you take 1 into W1 plus 0 into W2. So that will become 1 into W1, which is nothing but 1 again. 1 is less than 1.1. 1.1 is nothing but threshold value. So when you take both inputs 1 and 1, 1 into W1 plus 1 into W2, which will become 2. 2 is greater than 1.1. Then in that case it will fire. So that's what the peceptron for AND gate. In a similar way, peceptron for OR gate. Here also you have 2 inputs and 1 output. The corresponding weights W1 is equal to 1, W2 is equal to 1, and here I have taken threshold as 1. Even threshold value need to be the 1. Because in the case of OR gate, when this OR gate will fire, is to analyze in a similar way to the AND gate. As in homework, you analyze how this OR gate or peceptron for OR will work out. Just you do it by yourself. In a similar way to the AND gate analysis, here you do it for OR gate. Perceptron drilling. The perceptron is simply separating the input into 2 categories. Those that cause a fire and those that do not fire. So what are the inputs which are firing range? What are the inputs which are not firing? So it is drawing a line. Linearly separable. That's what we are calling it as linearly separable, the inputs. So it does this by looking at in the 2-dimensional case. The corresponding inputs are, if it is I1, I2, and threshold value is theta. W1 I1 plus W2 I2, if it is less than theta, that is, it is on the left side of the left hand side. Then if it is less than theta, it does not fire, otherwise it fires. If W1 I1 plus W2 I2 is less than theta means it doesn't fire. If it is greater than or equal to theta means it fires, right? It means it is separating into the two classes or two categories. That is, it is drawing the line with that equation W1 I1 plus W2 I2 is equal to theta and looking at where the input point lies. Based on the inputs and threshold value, that line is going to be placed on this two-dimensional plane. So when the points on the one side of the line falls into one category and the points on the other side falls into the other category, that means less than theta and greater than or equal to theta, right? Based on the input values, few points will lies on the one side of the line and few points will lies on the other side of the line. So that means one side of the line inputs will fire the neuron, one other side of the line inputs do not fire the neuron. Because the weights and thresholds can be anything. This is just any line across the two-dimensional input space. Based on the input and threshold values, that line may place at anywhere, any place, anywhere. So what the perceptron is doing is simply drawing a line across that 2D input space. Inputs to one side of the line are classified into one category and inputs to the other side are classified into another category, which is firing and not firing category. As an example, if we take our perceptron, let us take W1 is equal to 1, W2 is equal to 1. The corresponding threshold value I have taken here as 0.5. This weights and threshold may be anything. If you draw the corresponding line will be based on that weights W1 is equal to 1, W2 is equal to 1. The corresponding line will be for the inputs I1, I2. I1 into W1 plus I2 into W2 is equal to corresponding threshold value theta. In that case, W1 is equal to W2 is equal to 1 means I1 plus I2 is equal to 0.5. That is the line. That line across the input space we need to draw. So which separate the points of that input values. Input values are nothing but 0, 0, 0, 1, 1, 0, 1, 1. So in what way it is separating? If I1 plus I2 is greater than or equal to theta range, I1 plus I2 is greater than or equal to theta means based on that input values 0, 0, 0, 1, 1, 0, 1, 1, among those four combinations, the first three, let us take here 0, 1, 1, 0, 1, 1 will lies on the one side because I1 plus I2, 0 plus 1, 1 plus 0, 1 plus 1, which all are greater than that 0.5 threshold theta. That's why it will lies on the one side. Whereas other point, that is 0, 0, which is nothing but 0 plus 0, which is less than the theta, which is nothing but 0.5. 0 is less than 0.5, that lies on the other side of the line. That is I1 plus I2 is equal to 0.5. So the first 3 points in the firing, the corresponding inputs, by providing the corresponding inputs, the neuron will get fired, and by providing that 0, 0 point, the corresponding neuron do not fire. First 3 points will fire the neuron, and rest of the points do not fire the corresponding neuron. So we simply take here below that line 1 point at that is nothing but 0, 0. Other 3 points are 0, 0, 1, 1, 0, 1, 1. All those combinations will fire the neuron. As you might imagine, not every set of points can be divided by a line like this. Not all the points can be divided. Those that can be are called the linearly separable. That means which are divided, which are easily divided by a line, those are called the linearly separable. As we have seen with XR example, the corresponding XR example is nothing but it is linearly separable example. So in this case we have taken two input dimensions, but if we draw for these two input dimensions, we are able to draw a line, one dimensional line. One line is enough to separate the, and it will make into the two classes. One is firing, another one is non-firing. In n dimensions, we need to draw the n minus 1 dimensional hyperplane, because your equation will become w1 I1 plus w2 I2 plus and so on, wn in is equal to theta. In that case, you get the n minus 1 separating lines of dimensional hyperplanes. Okay. Earlier with OR gate, that is linearly separable, because there you are getting that simple combinations. One is fire range and the other is do not fire range inputs. But if you take the perceptron for XR gate, XR is where one is 1 and the other is 0, but not both. That means I think you know the XR, right? When that XR output will be 1, X1, X2. If you take both are same, means it do not fire, or output will be 0. For 0, 0 and 1, 1, your output will be 0 only. When both the inputs are different, that is either 0, 1 or 1, 0, then your output will be 1. So that's what it tells. In that case, what does it means? If you take that weights as W1 and W2 for the corresponding inputs 0, 0, 0, 1, 1, 0, 1, 1, in which case it will fire? When both the inputs are opposite. In that case it will fire 1, 0 and 0, 1. That's what the first two lines, that is 1 into W1 plus 0 into W2, which causes a fire a neuron, because 1 into W1 plus 0 into W2 is greater than or equal to theta, and 0 into W1 plus 1 into W2 is greater than or equal to theta. In those two cases your neuron will fire, because in those two cases only you will get the XR as 1. In other two cases 0, 0 and plus 1, 1, in that case 0 into W1 plus 0 into W2, which will be less than theta. In a similar way, 1 into W1 plus 1 into W2 also less than theta. Those two do not fire the neuron. So how many equations you got it here? W1 is greater than, from that 1 into W1 plus 0 into W2 is greater than or equal to theta, means from that you get W1 is greater than or equal to theta. Second line, W2 is greater than or equal to theta. Third line, 0 is less than theta. Fourth, W1 plus W2 is less than theta. All these, there is a contradiction to that linearly separable example, because here it cannot be linearly separable, because you are getting 4 different equations. So that's why it is not linearly separable. If we go in detail, so let us, we need all 4 inequalities for this contradiction, to solve this contradiction. If weights are negative, example, let us take, even though weights are negative, let us take weights are equal to minus 4. Both the weights are, let us take as minus 4, and the threshold value as minus 5. In that case, the weights can be greater than theta. Understood? Weights can be greater than theta. Yet by adding them, which is less than the theta. So simply let us assume the same way. Here you please note that weights as minus 4, W1 is equal to W2 is equal to minus 4, and theta is equal to minus 5. And go to that earlier slide and see that last 4 equations. W1 plus W2. Theta is equal to minus 5. What is W1 plus W2? W1 plus W2, which is nothing but minus 4 plus minus 4. Minus 4 plus minus 4 is nothing but minus 8. Minus 8 is greater than or equal to theta. here weights minus 4 and theta is equal to minus 4. One weight has 0, another weight has minus 4 also. First two will be satisfied. W1 is equal to, let us take W1 is equal to minus 4 and theta is equal to minus 5. Minus 4 is greater than minus 1. All the four equations do not satisfy for any. Even if you take that theta is greater than 0, is there, right? But if you take that theta is greater than 0, theta is equal to minus 5, here we have taken. But here theta should be greater than or equal to 0. W1 plus W2 should be less than theta. W1 plus W2 if you take both weights as minus 4 and minus 4. Minus 8 which is less than theta. Theta is nothing but minus 5. Minus 8 is less than minus 5. Last equation alone it has been satisfied. If we take W1 is equal to minus 4, W2 is equal to minus 4 and theta is equal to minus 5. W1 plus W2 is equal to minus 8 which is less than minus 5. Last equation satisfied. But what about that third equation? Theta should be greater than 0, right? In that case it will not satisfy. Because to satisfy that last equation W1 plus W2 should be less than theta means obviously we need to go for either negative values or one positive negative values. If we take any weights and any value of weight and threshold, all the four equations do not satisfy. That's why this is a contradiction and we cannot go with the single layer perceptron. So any one condition, any one equation among all the above four equations will stop that neuron do not fire. So that is a contradiction. That's why a single layer perceptron cannot implement with XR gate. The reason is because the classes in XR are not linearly separable. Classes means you got four groups or four classes, right? Combinations. Those are not linearly separable. You cannot draw a straight line to separate the points 0, 0, 1, 1 which are in the non-fire range from the points 0, 1, 1, 0. It is impossible to draw the single line between these two points. That's why the people have invented multi-layer perceptron networks or multi-layer networks. So as an example, as a general example for more understanding, here I have taken this as an example. So linearly separable classifications. See, if the classification is linearly separable, we can have any number of classes with perceptron, any number of groups of perceptron. For example, instead of classifying furniture according to the height and width, earlier I have taken two input case means here also let it be I1, I2. Instead of I1, I2, here I have taken width and height as an inputs. Width and height as an input. So what are the classes here? Tables is one class, chairs is one class, beds is one class, groups. So in this case, when your height and width both are less means it will come under the table category. In that way I need the tables, but I need less width and more height, the corresponding chairs will comes. But I need more width and less height, that comes under the beds category. So like that I need some classification. If we use some perceptron, we need to draw the lines or we need to categorize into these classes. If you see in the perceptron example, each category can be separated from the other two. One may be tables is separate from the beds and chairs. Beds is separate from the tables and chairs. Like this. So we can have a network which can draw the three straight lines. And each output node fires because three outputs are right. Inputs are height and width. H and W. Output is nothing but bed, table and chair. Each output node fires if you are on the right side of the straight line. Right side is nothing but which fires the neuron. One side of the neuron, one side of the straight line, right? So in that case, if you see each input height is connected with the three output neurons. Height is required for all the output neurons, that is bed, table and chair. It requires a minimum height. We need to classify that inputs or that outputs based on the height also. That's why all height is connected to the all outputs, as well as width is also connected to the all output neurons. Now if we see for these two inputs, height and height and width. When if we take the first output neuron, it draws a line, and if output neuron bed is fired, means it may be bed or not bed. In the similar way for table and chair, it draws a line and which fires the table or not table, fires the chair or not chair. Instead of taking with some zeros and ones, here I have taken with bed and table and chair. In that case, these three classes will come when it is satisfying. For example, on bed height should be less, width should be more. In that case, the corresponding height and width if you provide, and by adjusting that connection weights, you can get the proper classes. If you take the table, if you take the chair, so the corresponding classification will come according to the height and width of the height and width. Okay. So, perceptron, single layer perceptron. Thank you.